So in this video we're going to learn about Bohr models, named after Niels Bohr, who did a lot of stuff with atoms. Okay, so the most important thing is, why would we use a Bohr model? So the reason for that is because it's going to show the location of electrons, abbreviated E-, in their energy levels, which is really the space they take up in the electron cloud. Okay, so we already know that in a nucleus we have our protons and our neutrons, and so we also know that electrons go around the outside. However, really they're arranged into different levels of energy, and the farther away you go, the more energy those electrons have. Okay, so what we're talking about with the Bohr model is where the electrons are in these different spaces. Okay, so the main way we figure this out is by using the periodic table. The periodic table is arranged in such a way that it actually tells us a whole lot of information if you know things about it. So a couple things to remember about the periodic table in general are that the things that are going up and down, so the columns, are known as groups, and as we go across a row, that is called a period. And that's because we see that with the different chemical properties, things repeat periodically. So just like the seasons repeat every year, certain chemical properties will repeat with every single row of the periodic table. The other thing that's important to know is that groups are also known sometimes as families because they have a lot of similar properties because they're in the same column. Okay, so when we're doing a Bohr model, the number row you're in is going to correspond to the number of rings that you need. So if you're looking at an element in the second row, it would have 2 rings. The number of squares that you actually would count in order to get to that element, so keep in mind that's actually the same as the atomic number because our number of protons is going to equal our number of electrons in a neutral atom. Then the number of squares, or the atomic number of that element, is going to correspond to the number of electron dots that you will draw on those rings. Okay? Another thing about the squares is the number of squares in one row is going to be the maximum number of electrons that can fit in that particular ring. So if we look at a periodic table, what that shows us is that for the given rows, 1, 2, 3, 4, 5, 6, 7, then that's how many energy levels there would be for each of those rows. Looking also at what I was just talking about, if we're looking across a row, so let's say we're looking at energy level 4, notice that that has 2 squares here for 19 and 20, then there's 10 more here, giving us a total so far of 12, plus 6 more gives us a total of 18. So that's how many electrons can fit in the 4th ring. Okay, so let's do that for the rest of them. So row 1, if you have your nucleus in the center, or I should say ring 1, row 1 has 2 squares, so that means you can fit 2 electrons in the first ring. Row 2 has 8 squares, so you can fit up to 8 electrons in the second ring. The next row also has 8 squares, but then technically, based on some things you'll learn in chemistry, the electrons that are being represented by these elements actually fall into the 3rd energy level. So that means then that with the 3rd energy level, you have the 2 that are here, plus these 6, plus the 8 that are in the box, or sorry, the 10 that are in the box. So you have a total of 18 electrons that you can fit. So basically a pattern emerges, and I doubt we'll do any elements that are bigger than the 4th energy level. So the pattern that emerges is you can fit 2 electrons, then 8, then 18, and then for the 4th energy level, that's actually going to be even more for a reason that we're not going to go into, but we'll talk about that in chemistry if you go on to take chemistry. Okay, so let's do a couple quick examples. Alright, so let's start out with magnesium. I use magnesium for a lot of things. So magnesium's atomic number is 12, and I got that just by looking at the periodic table. Okay, so the atomic number is 12, which means there are 12 protons and also 12 electrons, right? Because we're only talking about things that are neutral right now. So these are the things that will be added to the diagram. Okay, so if we scroll back up to the periodic table, we see magnesium is right here, element 12. Notice that it is in the third row. Okay, so 1, 2, 3. So since it's in the third row, you would show that with 3 rings. Okay, so the way we show that is we write the symbol in the middle, and then you'll have 3 rings going around it. Hopefully your circles look better than mine. And we have to add 12 dots to these rings. So remembering our pattern, 2, 8, 18. Then I can show 2 dots on the first ring. Then I can show 8 on the second ring. So that's a total of 10 electrons so far. So I only have 2 more that I need to add, and therefore they'll just be on the third ring, but you just don't fill it up all the way. Okay? So there's 12 dots because there are 12 electrons, and there are 3 rings because we are in the third row. Okay, as another example, let's look at oxygen. Okay, oxygen is in the second row of the periodic table, and its atomic number is 8, so it will have 8 electrons. So if I'm writing that one or drawing the Bohr model for that one, I'll have my oxygen symbol. I'll only have 2 rings around it because it only has 2 energy levels. I can fit 2 in the first ring, and I can fit up to 8 in the second ring, but I only have 6 left over, right? I'm looking for a total of 8. So then you can just space your 6 dots around the outside. Okay? So you should have 2 in the first energy level and 6 in the second energy level. Okay? And the N means basically the ring that it's in. Alright, and so that's how you draw a Bohr model. So hopefully you have a practice worksheet that you've received and you can try some of those there. Good luck. Ask questions if you have them, please.